Here we have a coil system used on the field self-feedback loop. Initially, the system is constructed of phases that spiral around each other. The white checker here represents phase 1 on that winding. Blue checker represents phase 2 on that winding. And the red checker is the bottom phase 3 winding. Vice versa over here on this phase, then the space facing the camera, the stack. The blue is on top, phase number 2. Phase number 3 is in the middle, and white is phase number 3. As it continues its exit of its spiral loop, where it's in the middle on the behind coil. Each of the middle coils in the series are then reversed so that they're 1/6 out of phase, with the remaining phases surrounding it, resulting in a magnetic expansion of all the poles on the machine. Here on the machine, we're interested in the possibilities for the machine to run itself. And what happens is we have a destructive feedback loop, which we're going to try to demonstrate. Right now we're showing what the machine is doing with no field connections. Due to the rotational magnetism alone. And I like to get a lot of these shots for record, for snapshots, and we'll do that like that. And I'm going to run in there and connect the field feedback loop, then we'll show the field feedback loop. At 0.87, 0.6, 0.5, should have been engaged instantly, but now. See, we can't leave it engaged for very long. Try that again. (28, 30, and 27 volts). Let's see the amperages. Gonna tickle for one of the high voltage caps. That was amazing. That's all supposed to be disconnected. Okay, here we'll show what our no field conditions are. We just showed what we're doing here. Burn my belly. What we're doing here is we got this coil on top in between the ordinary secondaries. Ordinary secondaries have been disabled. However, I just got jolted by one of them. I must have done something wrong. In between the ordinary 9-coil system, 1, 2, 3 on each stack, 1, 2, 3 on each stack, we have this pancake coil of 1/4 ohm, I think it is. I think it's a 1/2 ohm, maybe. 100 feet out of 2. It's a 1/4 ohm. A 1/4 ohm there, and there. All in series. We call that the communist system because it's a forced oscillation because everything's in series. No matter what agreement is on the phases that's powering them, they reach a new phasing solution according to their series agreement. Okay. Then according to this series agreement, which on 3-phase should of course never be in time, we have voltage meters across all 3 of them sources, showing it the total of the 2.2 volts available to go to the field rectification. The problem on self-feedback loops is the fact that in the field self-rectification, producing the DC pulse back to field at twice of the frequency of operation. That, it costs 0.7 volts in each direction, or 1.4 volts in totality. And you can take that 1.4 volts right off the top of that 2.2 volts. This supply is enabled. Now, once again, we'll connect the feedback loop. Shortly again. See, we're obtaining 23 volts to field. And in that case, when you're obtaining 23 volts to field, well, by God, you ain't got to worry about the 0.7 volts you're losing on each side of the diode system. So then the system, of course, becomes more readily operatable. I think the reason that we're only going up to 23 to 30 volts is chain reaction is controlled in some manner. I'll show that again. 23 volts. If that's on camera, we can compare them phase angles. We got 28 to 30 volts, 7, 4, and 5 amps. We have to worry about our amperage lines. And so we can see then, we'll end this video and show once again close up of the field operation in this 10th embodiment of the wireless coil series. You should be able to see the voltage and amperage meters on when the feedback loop is changed. I gotta get out. No way. Son of a bitch. What is going on with that? How come I didn't touch nothing? 7, 4, and 5 amps, 28, 30, and 27 volts. And so that's what we get directly from the feedback loop, which we don't want to have. We're going to calm that down, tame it down with the secondary valve.